Okay, this is back to circles, and this is going to introduce radians and arc length with radians. Um, so circumference is the area of a circle. The circumference of a circle of radius 1 is 2 pi times radius, or 2 pi. 2 pi going around the circle equals 360 degrees. You probably know that from radian number. In the 14th century, astronomers and mathematicians were using the length of the arc of a circle to measure angles. In the 1400s, they calculated 2 pi correct to 17 decimal places, and the term radian was used by first in an examination question set by James Thorson at Queen's College in Belfast, Northern Ireland, I think, in 1873. Um, so it's important to understand this. This was first done by a Persian astronomer, and he set that goal. And they used this to calculate locations of celestial objects. So, radians. Radians are simply another way to measure an angle that is related to the radius. Um, the definition of radian. Well, you can use this. I say to convert radians to degrees, you multiply by, well, degrees to radians, you multiply by pi over 180. Radians to degrees, 180 over pi. That will let you end in degrees. Pi is the radian connection. Because half a circle, pi radians, that's a 180, 180 degrees. The definition of radian, arc length divided by radius. Pi is a beautiful number. It is simply the, you can watch this video later. It's kind of fun. But it's simply circumference divided by radius is what's defined to be pi. It shows up in all kinds of arcs. Do not ever use 3.14 or 22 sevenths. Use the pi button on your calculator, always. So an angle given as 40 degrees, its value in radians is to 3 significant digits. Simple conversion, 40 times pi over 180. I guess I'm going to have to use a calculator because it wants it to 3 significant digits. 4 over 18 is 2 pi over 9. That would be my preferred way to leave it. But seeing as the directions said to give it to 3 significant digits, I will take my calculator and go 2 times pi divided by 9 and get 0.698. This one it wants in degrees, 3. So my conversion factor, it's always 180 over pi. You could do 360 over 2 pi, but it's 180 over pi. Works nicely. $135. And I just reduced 3 times 90 is 270, cut in half. So this is not in your IB formula booklet. You have to know those conversions. Might be helpful to know the unit circle. Just kind of have it memorized. 1 radian is approximately 57.3 degrees. That's helpful information to know. just as a reference point. So arc length. Arc length is way easier to do in radians than degrees because the arc length formula, S stands for arc length. If your angle's in theta in radians, you just multiply theta times r. So a circle with radius 5 centimeters subtends an angle of 1.2 radians. Find the length of the arc. 5 times, I guess I did those backwards, but whatever, 6 radians, or 6 centimeters. I could give that to 3 significant digits, but I don't really need to. So a circle with now, that's pretty simple. A circle with radius 5 centimeters has an arc length of 8. Find the angle in radians. Oops. 8 equals theta times 5. 1.6 equals theta, because I'll divide both sides by 5. 8 over 5 is 1.6. And that's arc length. Yay, very difficult. Area of a sector. Area of a sector is area of a circle. So I'll develop this formula. So here was your degrees one. X over 360 times area of a circle. I'm going to take my degrees and I want it to cancel. So I want to convert my X to radians. So I'm going to multiply my X in degrees to radians. Actually, I want the degrees part to cancel. So it's actually backwards of that. I need the degrees to cancel. Let's write it out like this. Those cancel. I get X over 2. My pi's cancel. R squared. Or angle in radians, theta over 2, R squared, gives me the area of the sector if I am in radians. So there's that formula developed. Or here they've got 1/2 R squared theta. So the radius of a circle is 5 centimeters. Find the area of the sector that subtends a central angle of 1.3 radians. So what does that mean? It means essentially this. Subtends a sector 1.3. It wants the area of the sector. A equals 1.3 over 2 times 5 squared. And that equals 16.25. We'll call it 16.3. And I'm guessing this is square centimeters. Yes. They didn't give it to 3 sig figs, so, well, 16.25, fine. Usually that's the 3 sig figs, but, you know, whatever. So, the diagram shows if the measure of the central angle is 3, find the exact area of the shaded segment. So this is segment of a circle. So this is going to be the sector minus the triangle. So area equals the sector is 3 pi over 4 we'll just do times half instead of divided by 2, times 4 squared, minus the triangle. I'm going to use this area of a triangle formula. And that's the two sides with the angle between them. I'm going to take my calculator, make sure I'm in radian mode. And when I do this, I get 13.2 square centimeters. Oh, it wants the exact. Darn it. Okay. I guess I got to do this in terms of exact. So this is going to be 3 pi over 4 times half of 4 squared is 8. That'll reduce out to be a 2. So this first part is 6 pi. Minus half of 4 times 4 is 8. Times sine of 3 pi over 4. So these things group to be that. This sine of 3 pi over 4, if I look at my unit circle, it's over here, it's 45. So that is square root of 2 over 2. Those will cancel and become a 4. 6 pi minus 4 square root of 2, which is the answer it wants. It's approximately 13.2. And that is the end of today's lesson, I believe. Yep, that's 13, section 3.7.